We're going to use the substitution method, and we're also going to learn about the addition, which is also called the elimination method. So let's start with the substitution method. In solving using the substitution method, what we're going to do is solve for one of the two variables in either the first equation or the second. I'm going to solve for x in the first equation. So in the first equation, we have negative 1x plus 7y equals negative 16. So I'm solving for x. So I'm going to subtract 7y from both sides. That gives me negative 1x equals negative 7y minus 16. And then I divide each term by a negative 1. So this gives me x equals 7y plus 16. I'm going to put that inside parentheses. So what we're going to do is go back and use the second equation, the 3x minus y equals 8, and substitute 7y plus 16 in for x. So we have 3. Instead of x, we're going to put in 7y plus 16, and we have minus y equals 8. Distribute, so 3 times 7y is 21y. 3 times 16 is 48. Minus y equals 8. Combine like terms, so 21 minus 1 gives us 20y plus 48 equals 8. Now subtract 48 because we're solving for y. This gives us 20y equals negative 40. And then we're going to divide both sides by 20. So y would equal negative 2. So for our answer, we know our y value is negative 2. We have to find our x value. So the easiest way to do that is to go back to this equation, x equals 7y plus 16. So x equals 7y. Well, we know what y is. We just found it to be negative 2. So x would equal 7 times negative 2, which is negative 14, plus 16. So x would equal 2. So our solution for this system would be 2, negative 2. And again, you could plug in 2 for x and negative 2 in for y, and it should check in both of the original equations. So in the addition or elimination method, what we want to do is add the two equations together and eliminate either the x or y variable. So in some instances, we're going to have to multiply one or both equations to make that so, because when we look at this equation, or these equations, I should say, 10 is not opposite of 5, because if I add 10 and 5, that gives me 15. So that's not eliminated. And if I add 7 and 6, that gives me 13. So neither would be eliminated. So what we're going to do is multiply one or both equations so that either the x or the y is eliminated. So I'm going to rewrite the two equations. So it's your choice. So in this case, I'm going to eliminate the x. So in order for them to be eliminated, I have to make the coefficients opposite. So what I'm going to do is look for a number that both 10 and 5 go into, and they both go into 10. So my first equation already has 10 as a coefficient, so I need to make the coefficient of x in the second equation negative 10. So in order to do that, I would have to multiply it by negative 2. But I don't just multiply that term, I multiply the entire equation. So I'm going to rewrite the first equation, 10x plus 7y equals 14. And now I'm going to multiply that whole second equation by negative 2. And that gives me negative 10x minus 12y equals negative 24. Now I'm going to add the two equations together, and now it does what I needed it to do. The 10x and the minus 10x will cancel out, leaving me with only one variable. So now I add 7 and negative 12. That gives me negative 5y, and 14 minus 24 is negative 10. So then I'm going to divide both sides by negative 5. So y equals positive 2. Now I have to find my x value. So I'm going to go back to my original equations, either one. So I'm going to take the first equation, the 10x plus 7y equals 14, and substitute 2 in for y. So we'd have 10x plus 7 times 2 equals 14. So we'd have 10x plus 14 equals 14. I'm solving for x, so I need to isolate, so I'm going to subtract 14 from both sides. So 10x would equal 0. And of course, when I divide by 10, 0 over anything is 0. So my x value would be 0. And again, you can check your answer by plugging 0 in for x and 2 in for y into both equations to make sure that your answer is correct. Next example, again, we're going to continue on with the elimination method. So here I have 2x minus y equals 3 and 3x plus 2y equals 15. So if I added the equations as they are, neither x nor y would be eliminated. So what I need to do is multiply by whatever it takes to either make the x's opposite or the y's. I'm going to again make the x's opposite. So I look at 2 and 3, and the common multiple, not factor, multiple of 2 and 3 is 6. So I need to multiply the first equation in order to make the number or my coefficient in front of x 6. So I'm going to multiply that equation by 3. When I do that, that gives me 6x minus 3y equals 9, because I multiply everything. Now, my second equation, I need to make the coefficient opposite. So what do I need to multiply 3 by to give me a number opposite of 6? Negative 2. So now when I multiply, negative 2 times 3x is negative 6x. Negative 2 times positive 2y is negative 4y. And negative 2 times 15 is negative 30. So when I add, again, it's doing what I want it to do. It's eliminating one of the two variables. And that gives me negative 7y equals negative 21. And I'm going to divide both sides by negative 7. And a negative divided by a negative is a positive 3. So my y value is 3. I need to find my x value now. So what I'm going to do is go back to either one of the two original problems, and I'll take the first one, the 2x minus y equals 3, and substitute 3 in for y. 2x minus 3 equals 3. I'm going to add 3 to both sides. So 2x would equal 6. So when I divide both sides by 2, tells me that x is 3 as well. So my common solution for this system of equations is 3 and 3. So now we have another system to solve. We have 7x minus 8y equals 7, and negative 14x plus 16y equals negative 14. Again, if I add the two equations together, neither the x nor the y would be eliminated. So I need to multiply to make either the x's opposite or the y's. I'm going to do the x's again. And so when I compare 7 and negative 14, I know the common multiple is 14. In other words, both 7 and 14 go into 14. So since my second equation already has a coefficient of negative 14, I need to multiply this first equation so that my coefficient is positive 14. So I'm going to multiply by 2. When I do this, 2 times 7x gives me 14x. 2 times negative 8y gives me negative 16y. And 2 times 7 gives me 14. Remember, you multiply everything by that number. I didn't have to make a change to the second equation, so I'm going to copy it down just as it was in the original problem. And now look what happens. My x's are eliminated, exactly what I wanted, but also my y's are eliminated. So on the left-hand side, that leaves me 0. On the right-hand side, I have 14 minus 14, which also equals 0. So since my variables are eliminated, I'm not going to have a single solution. I'm either going to have no solution or an infinite number of solutions. Anytime we solve and the resulting answer is true, because 0 does equal 0, I would have an infinite number of solutions. If this were a false statement, this gave me 0 equals some number other than 0, then I would have no solution. Our next example incorporates fractions as coefficients. So this is something that bothers most students. So what I recommend doing, although it's not the only way, is before I deal with the elimination, I eliminate the fractions and then compare. So what you're going to do is look at each problem individually. So when I look at this first equation, I have 3/4 x minus y equals 1. The common denominator, or the least common denominator, is 4. So what I'm going to do is multiply each term by 4. So when I do that, in the first term, the 4's reduce, and that just leaves me with 3x. I have minus 4y, and then that's going to equal 4. So in the second equation, I do the same thing. So I'm not eliminating variables yet. I'm just eliminating the fractions so I can do this problem with less difficulty. So here the only denominator is 5, so I'm going to multiply each term by 5. And when I do that, that gives me 20x. Here the 5's reduce, minus 4y equals 5 times 28, which is 140. So now I need to eliminate either the x or y. So this is where I would do the comparison. In this case, it looks like it'd be much easier to eliminate the y's. So they both have coefficients of negative 4, but I need one to have a positive 4. So what I'm going to do is multiply the first equation by negative 1. And all that's going to do is change the signs. So this becomes minus 3x plus 4y equals negative 4. So when I multiplied by negative 1, it changed all the signs. So the second equation, I don't need to make a change at all. So now I add the two equations. And again, it's doing what I want it to do because one of the two variables is going to be eliminated. Negative 3 plus 20 gives me 17x. And negative 4 plus 140 gives me 136. So now you're going to take 136 and you're going to divide by 17. So x would equal 8. So now I need to find the corresponding y value. So I'm going to choose one of my two equations. I'm going to choose the 3x minus 4y equals 4 and substitute 8 in for x. So I have 3 times 8 minus 4y equals 4. So this is 24 minus 4y equals 4. Subtract 24 from both sides. This will give me negative 4y equals negative 20. And when I divide both sides by negative 4, a negative divided by a negative is a positive. So that would give me a positive 5. So my common solution would be 8, 5. Remember, your x value comes first, and then your y value. Our last type word problem is a little bit different. So what I recommend is being consistent on how you set these up. So here we have a distance problem. So we know the formula for distance. If you don't, the formula for distance is time times the rate equals the distance. In other words, if you traveled 2 hours at 50 miles per hour, you would have traveled 100 miles. Okay, so now let's read the problem. It says, against the wind, a small plane flew 715 miles in 2 hours and 10 minutes. The return trip took only 1 hour and 50 minutes. What was the speed of the wind and what was the speed of the plane in still air? So we have against the wind and with the wind. So let's look at rate first. So we're going to let P equal the plane in what we call still air. That means if it were a perfect day, no winds blowing, the rate of the plane would be the same. So if you have wind, we're going to let W equal the speed of the wind. So when it says against the wind and with the wind, if a plane's flying into a wind, it's going to slow the plane down. If it's flying with the wind, then the wind's going to push the plane faster. So now, against the wind, the rate is going to be the speed of the plane minus the wind. With the wind, it's going to go faster, so it's going to be the speed of the plane with the help of the wind. So in every single problem, what I do first is I set up a table and I just write against P minus W with P plus W. And then it's easy to put in the distance. So in here it says that the distance is 715 miles. So you've filled out already 2/3 of the table. Now the next part's a little bit trickier because they're dealing with hours and minutes. And when you're measuring speed, it's miles per hour or kilometers per hour, not per minute. So in this case, we need to express time in terms of hours. So it says, against the wind, it took 2 hours and 10 minutes. So 2 hours and 10 minutes is 130 minutes. So we put 130 over 60 to convert that to hours. The return trip took 1 hour and 50 minutes. So an hour is 60 minutes and another 50 minutes gives us 110 minutes. And again, converting it to hours, we divide by 60. So at this point, you have a couple of choices. One choice is to distribute these fractions times each one of these variables. In other words, multiply 130 over 60 times P and W. And then on the second one, multiply 110 over 60 times P plus W. But I want to offer a solution to make it a little bit easier. So just like we talked about before, when we solve an equation where the coefficient is a fraction, we can multiply by its reciprocal. So what I'm going to do is multiply both sides by the reciprocal of the time. So I'm multiplying the first one by 60 over 130, and I'm going to multiply the second one by 60 over 110. So when I multiply by a reciprocal, remember it reduces to 1. So this is 1p minus 1w now. Because remember, this reduces to 1, and when I distribute the 1 times each one, I get 1p minus 1w. Now, on the right-hand side, what you're going to do, depending on what type of calculator, you're going to take 715 times 60 over 130. So for those of you with just a scientific calculator, you take 715 times 60, and then you'll divide that answer by 130. And that should give you 330. So notice how simpler this problem has become. So now notice there's no fractions and the numbers are small. So for the second equation, when I multiply by the reciprocal, again, it reduces to 1. And when I distribute that 1 times each one, that becomes 1p plus 1w equals, I'm going to do the same thing. I'm going to take 715 times 60 and then divide that answer by 110. Okay, so now look how much easier the problems become. I recommend doing that on every single time you do these distance problems. Eliminate this number on the outside by multiplying it by its reciprocal. And now we're going to solve the system using addition. Look at what we have, and this will happen every single time if you follow this method. Look at the W's, negative 1W and positive 1W. That will be eliminated when we add. So all I'm going to do, I don't have to make any change to either equation. I'm just going to add straight down. So the W's are eliminated. That gives me 2p equals 720. Now I'm going to divide by 2. And p equals 360. What does p represent? The speed of the plane in still air. So now I still have to find W. So I go to either one of the two equations here. So I'll take the second one, the 1p plus 1w equals 390. And I substitute 360 in for p. So I have 360 plus 1w equals 390. I'm going to subtract 360 from both sides. And this leaves me with W equals 30. And what does W represent? The speed of the wind. So the speed of the plane in still air is 360, and the speed of the wind is 30. Again, my recommendation is when you're setting up the problem, write against and with, write your P minus W and your P plus W, and put in your distance, and then put in your time last. If you follow these steps, it's much easier to solve this type of problem.